сьогоднішню лекцію. Сьогодні ми будемо розглядати тему «Легка черепно-мозкова травма підвищує ризик психічних розладів та суїциду, тягар проблеми» для наших друзів в українській армії. Сьогоднішня лекторка Ліза Бреннер, доктор психології, відділу ветеранів університету Колорадо, медичного кампусу Аншутц. Лекція транслюватиметься українською мовою і триватиме 1 годину. Запитання, які виникнуть протягом лекції, можна поставити або наприкінці, або впродовж лекції писати у чат і потім отримати відповідь на них. Тренінг буде записуватись, а згодом його можна буде переглянути на YouTube-каналі громадської організації «Форпост». Також зазначаємо, що лекція приходить з синхронним перекладом. Тож можемо розпочинати. Будь ласка, пані Ліза, вам слово.
Thank you so much. I so appreciate the opportunity to be here today and to present on this topic and look forward to your questions and just grateful for being invited to do this. As always, need to highlight that everything I'm going to say today is me and not the Department of Veterans Affairs, and that there was no commercial support received for this activity. I think Dr. Castro asked me to speak because I have been thinking about the idea of kind of mental health and brain injury for some time. And really, this came out of my work at the beginning of the conflicts in Afghanistan and Iraq, when we were seeing folks come back and individuals were coming back with what seemed like symptoms related to TBI, and also symptoms that seemed kind of like mental health problems, but not really one or the other. And one thing that we really noticed was that it just looked different. And I'm embarrassed to say myself and many people at the beginning of the conflicts in Iraq and Afghanistan spent an inordinate amount of time trying to figure out were the symptoms associated with a mental health condition such as PTSD, or were the symptoms associated with something like brain injury. Then I think eventually I just gave up. Being a psychologist, I knew that mental health conditions often happen in the brain, though we experience things in the gut and other places, which I'll talk some about today. And brain injuries actually happen in the brain. So could we start to think about these really as being both brain-based behaviors related to brain health, conditions that impact one another and that actually exacerbate each other? And if you're going to take this perspective, then you actually need to start looking back over time and think about what has happened with this individual's brain over time, and how might this most recent exposure, and whether that exposure is a mental health condition or mental health symptoms, or exposure to a psychological stressor, or a physical exposure such as a brain injury, how might those things accumulate over one's lifetime and impact their current health and then long-term outcomes? So one thing also that we really heard quite a bit about at the beginning of the conflicts in Iraq and Afghanistan is, why are these individuals having such a hard time? They had one mild traumatic brain injury, and they're reporting persistent symptoms, and that's not consistent with what we know about persistent symptoms. And so I began to get really interested. Okay, well, what is happening in the context? What context are these brain injuries happening in? What happened to them historically? And we had the opportunity to go to Fort Carson in Colorado Springs and actually ask folks about their lifetime history of traumatic brain injuries. And in doing so, I had the pleasure of interviewing one individual, and he's my rodeo rider here. This isn't him, of course, but and he told me that before he joined the military, he was in the rodeo. I'm not sure if there's an analogous word in Ukrainian for rodeo, but he would get on bucking broncs and bulls and ride, and had sustained many brain injuries before deploying to Iraq and Afghanistan. And I always think about him when I'm talking about this. So what we did at that time, the Department of Defense was using a brain injury screener, a BTBIS, and the OSU is a clinical interview for history of TBI. So what we had here was people that were screening positive for a recent brain injury on their deployment, or positive on the interview, so the long-term clinical interview, life course history, brain injuries all the way back. And then we had folks that were screening negative, but also positive on the OSU. And what we found is across the board, people had many, many brain injuries. And even those who screened negative for TBI at the time that we were interviewing them, so did you have a recent brain injury, had many lifetime TBIs. And so what we found is that even if you screened negative for a recent TBI, you had a lifetime mean of 2 TBIs. And if you screened positive, you had a lifetime mean of 3 TBIs. Up in the corner here, you see this figure, and my poor team worked with me to make this. And what you see across the bottom is time in years prior to the latest TBI assessment, and the counts of brain injuries and the counts of individuals. And so what you have here is, and you see in the top in the different colorings, that you have, this is the individuals. So this is counts of TBI, sorry, on the y-axis. And what you see here is the different colors highlight the different brain injury that this was. So time 0, so that was folks who had sustained brain injuries during this most recent deployment. For some people, this was their 5th brain injury. That's the darkest color. For some people, this was their 4th. For some people, this was their 3rd. And what you see is dating all the way back to 25 years post, people had brain injuries long before the brain injuries they received in Iraq and Afghanistan. And this is particularly important in terms of this idea that there's mounting evidence that parts of the brain, microglia, become primed, and they become hyperreactive, so that if you have a primed microglia in the brain, it becomes more responsive to exposures in the future. And that hyperreactivity and the more responsivity is one of the ways that we are beginning to understand it, is that you have exaggerated pro-inflammatory responses, and it creates a pro-inflammatory phenotype, and that may make you more susceptible, as you will see as I go along, to future negative outcomes. Just to switch for a minute, I think we don't often think about kind of inflammatory responses resulting in depression. But this was something completely different. This is from a study on the influenza or a flu vaccine. And what you had here was that there were individuals, this is older adults who were given the flu vaccine. And at baseline, we had folks that had more depressive symptoms and folks that had less depressive symptoms. You can see here on baseline. You can also see that folks who had more depressive symptoms had higher IL-6, or hyperinflammatory or more inflammatory at the beginning. And then what happened is this wasn't my study, they gave everybody an influenza shot. And those who started out to be primed for exposures, so they had more inflammation at the beginning, actually had an increased inflammatory response after the influenza shot. And not only that, they reported more depressive symptoms after that. This was versus the folks who didn't have too much depression or inflammation at the beginning, and then had not too much depression or inflammation after the influenza shot. In terms of military, this is one of my favorite studies that I talk about quite a bit. So this is plasma CRP concentration levels. So this is C-reactive protein before deployment. And what they found in this marine resiliency study was that there were about 3,000 individuals deployed, and adjusting for baseline PTSD symptoms and trauma exposure and other covariates, individuals who had higher plasma C-reactive protein initially, before they were deployed, they were more likely to develop PTSD than those who did not have high inflammation. So again, this idea that you have this exaggerated, potentially inflammatory response happening, then you're exposed, and then you have an outcome that could be associated with higher inflammation. We can look at this the other way too. So if we look at problems with immunoregulation, which goes along with hyperinflammatory or hyper-exaggerated inflammatory responses, here we've got evidence of inadequate immunoregulation in PTSD. And this is just across the board looking at autoimmune conditions in individuals who have PTSD. And what you see is across the board, individuals who do have post-traumatic stress disorder are more likely to go on to develop a wide range of autoimmune conditions, including MS, multiple sclerosis, rheumatoid arthritis, inflammatory bowel disease, and lupus. So again, linking this idea that PTSD, which we think of a mental health condition, actually may be related to inflammatory processes for some individuals. Okay, so I'm sorry if I'm switching back and forth between TBI and mental health, but I guess that's the whole point of this talk, is that these things are really connected and both happening in the brain. So what do we know about inflammation following a TBI? Well, we certainly know that the central nervous system, we have an inflammatory response, and the injuries could cause a cell memory disruption, that you could have vascular disruption, that you could have blood-brain barrier damage, and that there's also secondary reactions and releases of all kinds of chemicals. And ultimately, we have some cell death in response to this. However, that we know that while these cytokines and cytokines and all these things that are necessary to help clean up brain injuries occur, it may be that for some individuals, they occur more than they should, and that we have an exaggerated inflammatory response or an over response that then results, as you see here, it becomes a more harmful response than a protective response for some individuals. And again, here on this graphic that Dr. Simon and colleagues made, there's important factors to consider when thinking about this immune response. So, you know, what is their age? What is their sex? What is their history? What is the mechanism of injury? And do they have previous TBIs or previous mental health conditions? Were they drinking at the time of the injury? Do they have a history of sleep deprivation? What are all the things that we know that cause inflammation? And how might that have impacted both inflammation at the time of injury, but this idea that you would have systemic long-term, not just 14 days, but maybe month to year an inflammatory response. Okay, so why is this important in terms of mental health conditions again, and how do we understand it? So I spent a lot of time trying to think about bodies and brains, and how do we begin to not only understand this hyperinflammatory process, but again, how do we maybe intervene on it? And I know one thing that has been challenging for all of us is that we've had some limitations in terms of kind of addressing blood-brain barrier issues and also addressing kind of new ways to get at the brain with interventions. So could we begin to look at other parts of the body? And so much of this is luck. Chris Lowry is at the University of Colorado Boulder, and I started to realize the work that he was doing. And he had written this article with Graham Rook some time ago, where they had started to think that some psychiatric disorders in developed countries may be attributable to challenges with immunoregulatory circuits to terminate inflammatory responses. So again, like I was just saying before, for some individuals, they may have more challenging outcomes following a brain injury, have more post-concussive symptoms because of an exaggerated inflammatory response. There may be some individuals that have an exaggerated inflammatory response in response to psychological stressors, and that this results in psychiatric conditions. And so what is causing this? And what Dr. Rook and Dr. Lowry hypothesized is that we evolved as human beings, we evolved with other species, and that these species were with us and have been with us always. They are things that have been ingested into our lungs, into our mouths, or in the food and water. We got them from our mothers when we were nursing. And these are different bacteria and viruses that we actually count on. And these bacteria and viruses actually have jobs that they help us regulate inflammatory responses and immunoregulatory processes. And for a number of reasons, and those reasons may include living in more urban settings, having more sterilized food, overuse of antibiotics. And believe me, I am all for antibiotics when they're needed. I'm all for cleanliness, all for all those things. It just may be that we have overdone it to a degree, and that overdoing it has resulted in less exposure to these old friends, as they call them, and that these old friends are really necessary to help keep us in check in terms of inflammation. And here's another article by Dr. Lowry, and I really like this article because he really brings it very specifically home to the idea of depression. And he talks about, well, what's the role of the microbiome? And his colleague Flux, they talk about the role of the microbiome in regulating things like depression. And you can go bottom up, so gut-brain axis or brain-gut axis on this. But what you see is that it's bidirectional. It's through the vagus nerve and probably through other things also, including blood. And what we are beginning to understand is that I'll go from bottom up. Exposures, actually, I'm going to go from top down. Exposures in the brain, so psychological exposures or physical exposures, impact the gut microbiome. The gut microbiome then impacts the gut and the lining of the gut, and that can create things like intestinal permeability, so that things that get that are in the gut that are supposed to stay in the gut get outside and get into the blood and cause more systemic inflammation that then can impact the functioning of the blood-brain barrier and what's happening in the brain. So again, how these things all fit together is something that's I know that I'm doing quite a bit of work on, and other people are too. But this idea that the brain causes chemicals, the gut microbiome causes, we'll say chemicals, those interact and also interact with other parts of the body that can then cause this cycle of inflammation and then depression in this case. Okay, so in terms of brain injury and mental health, we do know that these things occur together. And so here, this was one of the studies that really got me on track in looking at this. This was a study of traumatic brain injury that was done by Richard Bryant in Australia some time ago. They basically found folks in the emergency room, and the folks in the emergency room, they followed them for 1 year post brain injury and found that 31% of individuals reported a psychiatric disorder after a brain injury, and 22% developed a new condition. So again, these individuals didn't have any history of psychiatric illness, and then they developed a new one. And the new, most common new psychiatric disorders were things like depression, generalized anxiety disorder, PTSD, and agoraphobia. This is a study that was done by our colleagues at the University of Washington. This is folks who had more severe injuries. They came to the emergency room. They were hospitalized. And what Chuck found is that during the first year after TBI, about 53% of people meet criteria for major depressive disorder at least once. The prevalence is highest in the first month. And then it actually, there's still new occurrences throughout the whole year. Certainly some of these are adjustment-related challenges related to TBI, but it may be that there are also physiologic challenges post-injury. And another, I hope you're convinced, but I'll keep going. Here's another study where this was where we looked at minor depression, so 2 to 4 symptoms, and major depression. These are individuals who had sought care in the TBI model systems. So more severe injury in this case, more severe than Richard Bryant or Chuck at University of Washington. And 22% of this sample reported minor depression, and 26 reported major depression at 1 year post-injury. Depression was associated with sex, age, pre-injury mental health treatment. So again, this idea that you had pre-injury mental health conditions or substance use. Oh, sure. I'm so sorry. No, I'm so sorry, and I know better. So I will tell me again, because I'll start to speed up again. Sure. So in this, should I go back or this slide? Okay. So in this in this cohort, so this is a more severely injured cohort, 22% of the sample reported minor depression, and 26 reported major depression at 1 year post TBI. Again, things that we've talked about that we know could increase risk for developing depression were present, and they did predict depression in this cohort. So again, the priming idea, pre-injury mental health treatment and substance abuse. The other thing that I think is really important about this is that all these folks really were engaged in care, and probably some of the best TBI care that we have in this country in the United States. And, you know, the sense is that their depression is not being addressed appropriately because they are still having depression even a year out after receiving very high quality health care for TBI. And so the study highlights not only the importance of assessing and treating depression, but also that when you don't, we found that folks had poor outcomes, poor satisfaction with life, and just more disability when their depression wasn't treated. The other thing I want to say is we did a follow-up study to this, and we found at the next time point, folks still had depression. Even though they were engaged in this long-term longitudinal study, they still had high rates of depression, and that these rates of depression were not being addressed, and that folks continued to kind of bounce from major depression to minor depression, but never completely out of depression. Okay, so back to Fort Carson with our DoD folks. Again, I had this idea that, well, what we should do is we should have them do timelines, and they should do timelines of their exposures, their physical exposures, and their psychological exposures. And not only should they do that, they should also tell us which symptoms they think are related to TBI and which symptoms are related to PTSD, just to see if they had an idea. So this is a timeline from somebody. They were deployed. They were exposed to a traumatic stressor, so something emotional. And then they sustained a mild TBI and had mild TBI symptoms. They returned to the United States, and they still were experiencing mild TBI-related symptoms. They were diagnosed with PTSD and received medication treatment and then redeployed. This individual then went on to have a suicide attempt. I think really importantly here, there's a different paper that I'm not presenting here, but what we found is that our soldiers did not know which symptoms went with which conditions. They thought that TBI symptoms were related to PTSD, PTSD symptoms were related to TBI, and it may be that these symptoms are more confusing and not as easily classified as we might think. And I'm going to show some data that suggests that. Again, this is data from Fort Carson. This is soldiers with histories of physical injury, mild TBI, and PTSD. And in these individuals, both conditions, so TBI and PTSD, were at increased risk for reporting post-concussive symptoms, so headache, dizziness, balance problems, than those with either PTSD, mild TBI, or neither. So 4 groups. If you had nothing and any of those symptoms, headaches, dizziness, balance problems, those who had PTSD were about 3 times more likely, those who had TBI 4 times more likely, and those who had both 6 times more likely. I do want to highlight here, we're talking post-concussive symptoms, and those with PTSD but no TBI were still 3 times more likely to report them. We know these symptoms are nonspecific, and I think it's really important to know. Here, again, memory problems, hallmark symptom of brain injury. So those with brain injury, about 6 times more likely. Those with both, almost 13 times more likely. But those with just PTSD and no TBI, 4 times more likely to have memory problems. Dizziness. I don't think we often think of dizziness as a PTSD problem, but here you are more likely to report dizziness if you had post-traumatic stress disorder than if you had brain injury. Balance problems, same, PTSD 5 times more likely, TBI 6 times more likely, and both 13 times more likely. Okay, so I'm going to switch again. Am I supposed to take questions at the end? I'm happy to stop too, or?
Yeah, we'll take questions at the end, and again,
Okay.
just slow down a little bit.
Okay, I will keep trying. That's not my best skill, but I'm working on it, and I appreciate you telling me. Okay, so I'm switching. This is suicide and traumatic brain injury. And when I started down this path, I think there was still some question as to whether these things were really related. I think we're kind of out of that now. So this was an initial study. I'm sorry, this is an initial study that was done in 2001. This was done by Teasdale and Engberg. And what they looked at was, do folks who have a history of TBI, and this was mild, moderate, and severe, have a history of increased risk for suicide? And what they found, this work can only be done with very, very large data sets because TBI, whether it's mild or moderate or severe, and it's also suicide, are relatively kind of low base rate behaviors, although each suicide can really impact, of course, many, many people. To get enough brain injuries co-occurring and time passing to allow suicide risk to develop and then to be unfortunately realized, it just takes time and lots of data. And what Teasdale and Engberg found was that that the risk of suicide was consistent for the full 15-year period. That's when they stopped actually looking at data. That's all the data they had. And so that people that had a history of TBI were at increased risk over this very long time. And that not only were they at increased risk for this very long time, that there were other things that made it even more problematic, like substance use. And so if folks had a history of substance use and emotional distress and TBI, they're about 21 times more likely to die by suicide than those that didn't have a history of TBI. So this inspired us to do this study with veterans. This is actually data really before Iraq and Afghanistan. It took a while for folks who were serving in the conflicts to actually start getting care in the VA. And what we found here was that individuals, again, with a history of TBI, and we needed about 8 million records to do this. So in the United States, there are very few integrated medical records and integrated healthcare systems that could allow for this kind of analysis. And in this case, we were very interested whether if we actually controlled for psychiatric conditions, which we know are a sequela of TBI, if TBI itself, just the brain injury itself, increased risk for suicide. And what we did find in this case is that the brain injury itself did increase risk in addition to increasing risk for new onset psychiatric conditions. We decided to do this again. This was more recently because we wanted to see, does this still stand for individuals who served in Iraq and Afghanistan? So in this, veterans with a history of TBI were about 2 to 4 times more likely to have a psychiatric diagnosis than those without a history of TBI. And veterans with any TBI, so this is mild, moderate, and severe, were more likely to die by suicide compared to those without a history of TBI. So having a worse brain injury was worse also. So history of suicide was about 1.62% higher for those with a mild TBI compared to those without, after adjusting for covariates. And those who had a history of more moderate to severe TBI were about 2.5 times more likely to die. One thing that's really important, and this is particularly an issue for us here in the United States, is that individuals who are veterans are more likely to die by suicide using firearms. And I think often we think about people who do have these very, very severe injuries, do not have access to firearms. And it's actually something here that we don't do a very good job about in terms of when individuals go home after a long hospitalization. We do lots of asking about the environment. We ask about rugs that they could trip over. We ask about, is their toilet seat high enough so that they can sit down on it? Do they have grab bars in their shower? We actually don't ask about firearms. And what we found is that individuals who had a history of more moderate to severe TBI were actually more likely to die by suicide using a firearm than those without a history of TBI. So again, I just want to clarify, this is veterans with a history of moderate to severe TBI were even more likely to die by suicide using a firearm than veterans who did not have a history of TBI. We know that veterans without a history of TBI, about 70+% of cases of suicide are by firearm. And so this is just a very startling finding. And for us, really made us think we probably need to change practices in terms of how we do home visits and how do we assess for safety when people leave the hospital. Okay. Oop. The other thing this work highlights is that there are factors that our medical records don't allow us to do a very good job at understanding. So here, we looked at racial and ethnic differences in death by suicide and drug overdose. And here we looked at opioid-related overdose, drug overdose, and suicide. If you are in this space and looking at these deaths in the United States, there is a very clear Venn diagram, so overlap between death by suicide, death by drug overdose, and death by opioid-related overdose. And the thing I just want to highlight here is that there were differences by race and ethnicity, and we've already talked about kind of race and ethnicity before as a factor that may contribute to inflammation, and not only race and ethnicity, but also circumstances in which people live, potentially not having, as many resources, and other social determinants of health, poor access to healthcare, long-term exposure to stressors and racism, and other factors that can impact outcomes. Interestingly, we found here that the category other, those that were in the category other, were at highest risk for death by suicide and by drug overdose. And this is really challenging because what is other? I mean, how do we begin to understand what other is? How do we begin to clarify factors that let us know that what people bring to brain injuries that may create further risk over time? Okay, so although we know that brain injury increases risk for suicide, and it's not just us, there's other studies that have been done, and there was a recent meta-analysis that found that history of TBI or concussion, in this case mild TBI, was associated with a twofold risk for suicide. It really leaves us asking for whom, when, and under what circumstances. And Dr. Baraney and I were asked to write a piece in Nature Reviews and really taking this life course perspective. And in this life course perspective, back to my brain injuries over time, what we're really trying to get at here is what are pre-injury factors? What are post-injury factors? What are genetic factors? How many injuries did you have? And can that help us understand what risk or priming you might have going into any brain injury? And Dr. Baraney and I, in this article, talked about this idea of an accumulation of life events and adversities, including those that are deployment related. Again, this idea of going back in time and looking. And this is something actually I started writing about with colleagues quite some time ago, 2009, and really beginning to think about, like, how do we stack adversities, right? How do we stack adversities over time? And how do we begin to think about life course trajectories? Now, what do I mean about life course trajectories? I think an easy way to think about it is childhood obesity. If we think about childhood obesity, you've got two groups of kids, a group that has childhood obesity and a group that doesn't. The group that has childhood obesity may go on to develop very early challenges with childhood diabetes or type 2 onset diabetes, right? At an earlier, maybe early adulthood. So these folks are already on the different trajectories than those that don't. And you keep having this trajectory that changes and changes over time, and you accumulate more and more challenges as you accumulate these adversities over time. This idea of a accumulation or cumulative disadvantage actually was first introduced by Merton in 1968. And Merton introduced this having nothing to do with health. This was introduced looking at disparities in career trajectories of scientists. And what they noted was that individuals, and in this case, they were actually looking at women versus men, women had less peer recognition. They didn't have as much access to resources. And what it resulted in was a different lifetime trajectories. These, the lack of access accumulated over time, and these inequalities became accentuated and resulted in very different outcomes in terms of scientific productivity. Orand and others have taken this and used it to think about health conditions and looked at the intersection between institutional mechanisms, so things like not having access to resources, back to the social determinants of health, poor housing, lack of access to education, minoritization, other things that happen for individuals and individuals' differences over time, and how that interplays with things like on an individual level like genetics, and that these interplay create this heterogeneity or inequality between aging cohorts that cascade and can cause physical and psychological health outcomes. Okay, so this is an article that we published this year. Finally, we had a large enough data set. And this gets back to, you remember at the very beginning, I talked about, is it TBI, is it PTSD, or is it both? And do those somehow relate to each other in a way that leads to longer term bad outcomes? And so we were able to get a data set, this very large data set that we were able to look specifically at, were those with TBI at risk of developing new onset mental health conditions? And then could that onset of new mental health conditions be associated with suicide? And could TBI be associated with suicide? So what we really were looking at here was, is there a direct and indirect association between brain injury, death by suicide with mental health as a mediator? And this is new onset mental health conditions. I've already told you several times, so there's no big surprises here, that those with TBI go on to develop new onset mental health conditions. So you're not going to be surprised when I show you that they do. And that we were able, in this very large data set, this was about 900,000 individuals, and we were able to look from the time they got a brain injury in the military, so an index TBI, all the way to the time that individuals died by suicide. There was, in this group of about 900,000, there was a group of 108,000 who had a history of TBI. We were able to use something called the National Death Index to look at death by suicide. And I want to highlight here, and I'm going to show on this next slide, how hard this research can be to do, because you have to have some shared decision-making about what codes you're going to use to come up with these diagnoses and how challenging this can be. And you can see some of the limitations of this. At the beginning, and this is no hit on anybody, this is just how challenging it was during the conflicts. But at the beginning of the conflicts, I think folks, myself included, did not realize that brain injury would become a big thing. And so at the beginning, and Carl, I'm sure, can speak to this, Dr. Castro, much in a smarter way than I can. But that, you know, I think we realized pretty quickly that that individuals were sustaining brain injuries during these deployments because of a changed battlefield and changed exposures, and that also people were living with brain injuries more than they had in the previous conflicts. And because of that, there were some policy changes that resulted in things being classified as TBI that actually are not TBI. So I'm going to take a step back. Brain injury is a historical event. It's an injury event with an associated alteration in consciousness. So it's not a head injury. It's not a personal history of any other injury. It's very specific. And so you have to have that injury event and alteration in consciousness. And what ended up happening, and I understand why, because that folks were trying to identify individuals who may have been missed that had a brain injury so that they could get care. But this definition of brain injury was expanded to include things that, again, do not meet criteria. And so there were some very non-precise codes, and also the Department of Defense created some ICD-9 and 10 codes that actually don't exist anywhere else, so you can't follow them into medical records and other systems. So what we found is this is a different paper, so I'm taking a break from the suicide paper. Sorry to take a break for a second, but I just want to talk about the methods for this and how hard it can be. But 73% of military members were captured with DOD case definition that were non-precise TBI codes during the window. So that's about 120,000 military members. So if you said, you looked at the number here and 2 slides ago and said 108,000, that seems really low, Lisa. We know rates of TBI were really high. In this study, we were very conservative. We were very, very conservative of the TBI definition that we used. And we took out everybody who had non-precise codes. Okay. Are folks following me? So if you had a personal history of other injury that was coded, which by the Department of Defense was a TBI, we took all those out for this analysis. And so 12.6% had a history of TBI. Most of the cohort was young at the time of brain injury. They were male. They were mostly white, although there was some diversity that really matches what's in the military. And want to stay here for a second and talk about this slide. So what you see on the left is history of TBI. So 108,000. What you see on the right is no history of TBI. I want to call your attention to where it says before versus after change and new onset after TBI. So if we look at anxiety, for the history of TBI group, they had a 74.8% change in TBI, and the new onset rate for them, so this is a new onset anxiety disorder, because we were able to look back in their medical records, was about 25%. For the group that did not have a TBI, about 10% developed a new anxiety disorder. For mood, 67% for the TBI group, which was about 22.4%, had a new onset mood disorder, and versus about 8% or 9% in the non-TBI group. I can keep going. So the PTSD group, 23% or almost 24% new onset PTSD diagnosis for the TBI group versus 6% for the no TBI group. I also want to highlight the alcohol use, also almost double, and the substance use almost more than double, almost triple. So, and the largest disparity was observed for substance use disorders, in which soldiers with a history of TBI had a 100% increase compared to a 14.5% increase among those without a history of TBI. So again, this idea that TBI creates risk through mechanisms, which we're not totally sure about, and for new onset psychiatric conditions. So this is looking at, I'm going to go back to my model, sorry. This is looking at the direct association, I'm about to talk about the direct association between TBI and suicide. So the direct association for TBI to suicide, so those with a history of TBI, and it differed depending on what conditions they had, but overall, those who had a history of TBI, time to suicide was about 21.3% faster than those without a history of TBI. And this was accounting for a number of things. And we can look at it then by different conditions. So for those with adjustment disorder and TBI, they were about 16 or about 17% faster time to suicide than those without. Okay. So then I want to look at the indirect effects. So this is through the new onset mental health condition. The largest indirect effect estimate on suicide was observed for those with substance use. So you remember that I said with Teasdale and Engberg that substance use was a huge problem. And same for these veterans or soldiers at the time. The time to suicide was about 62.8% faster for those with a substance use disorder. But it was faster across the board for all the mental health conditions through new onset mental health conditions. I already talked about some of the limitations of this. Really hard to do this work and come up with kind of all these variables using medical records. But I think the main thing, the takeaway is that really there is both indirect and direct effects through new onset mental health conditions and from the TBI. So that leaves us with why? What's causing these? What's causing this? And I'm going back to the beginning of the talk where I talked about inflammation some. So in the Department of Veterans Affairs, there are grants that you can write that begin to look at whole models. And you do this by looking at things that may impact conditions of interest. And the great news about this is you get to bring together teams from across the VA and the Department of Veterans Affairs. And so the model that we're very, very interested in is looking at cognitive control. How does a brain injury impact cognitive control, emotional regulation, autonomic functioning, so things like heart rate variability and responsivity, suicide attempts, how is that impacted by gender, inflammation, and the gut microbiome? And you can see everywhere it says RMR, MC, that's me, Rocky Mountain Regional Medical Center. So the parts that I'm looking at, and this won't be surprising to you from what I said at the beginning, is that I'm particularly interested in looking at brain injury, cognitive control, so kind of how people think about things. And we've looked at inhibitory control or executive functioning. How do people think themselves out of a suicidal crisis or not? Are they impulsive? Can they sustain attention and come up with alternatives to suicide, or can they not? Here's our executive functioning paper that we did some time ago, where we found that folks that did have a brain injury have a harder time problem solving. And we look at prediction. So predicting risks using, again, a no-go task. So again, can you use neuropsychological measures to look at things like sustained attention and inhibitory control? And then can you look at the microbiome, blast, leaky gut, so intestinal permeability, things getting into the blood that shouldn't be, and inflammation to begin to look at why. Why is it that TBI increases risk for both poor mental health outcomes and suicide? And this work, I mean, it takes tons of people. And I want to say, like, in specific, the microbiome work, when I started doing this work, people are like, you are nutty. Lisa, why? What does the microbiome have to do with mental health? Seeming like I'm maybe less nutty in this case. But this work is very challenging, and the science is very new. Also very new science in terms of kind of trying to find things like intestinal permeability, so leaky gut. we did a cross-sectional study looking at, I should say that looking at leaky gut's much easier in animal studies where I don't do that work, but where people who are looking at animals can actually look at the gut. Obviously, we cannot look at guts of people, nor would we want to. But we did a cross-sectional study of assays, so blood-based biomarkers for intestinal permeability, things that are on the market that you can use. We did 9 different assays that you can buy. None of them were correlated. So we have problems with measurement right now with all this. So very theoretical. Well, why do I feel motivated about this? Well, I feel motivated because if this could work, we interventions that would address things like post-concussive symptoms and post-traumatic stress disorder by addressing underlying mechanisms. So this is a study that we did some time ago, not that long, published in 2020. Here we used L-reuteri, a probiotic, and we were interested in mechanisms here. This was a very small study. And what we did is we recruited individuals who had current post-concussive symptoms, so headache, dizziness, balance problems, and current post-traumatic stress disorder. And we wanted to look at some of these markers. Before, you remember I talked about C-reactive protein in that Marine cohort where they had high C-reactive protein before they were deployed, more risk of developing PTSD. So we were interested in CRP, so C-reactive protein, as a potential indicator of inflammation that's important in post-traumatic stress disorder. And then we also, in this case, were interested in autonomic functioning in terms of stress. Also particularly important in terms of treatments, best treatments for PTSD. As I'm sure you all know, and you've had lectures about, PTSD treatments can be really, really hard to do because they are stressful. We ask people to think about their trauma, and they don't like it. And it makes people really anxious, and there's very high dropout rates. So if we could make people less physiologically reactive to that post-traumatic response, it may be that we actually could help them stay in treatment more. Anyway, we gave folks who had both of these conditions, both current symptoms, L-reuteri for 8 weeks, an immunomodulatory probiotic. And we found a couple things. After 8 weeks, and again, this was a very small study, like I'm having trouble remembering, but I want to say like 20 and 20. We found that their inflammatory marker was almost significantly different after 8 weeks of a probiotic. And we also found during something called the Trier social stress test. And I don't know if people are familiar with this test. It's a mean test. We have people come into a room. We have our lab coats on. We have like clipboards. We ask them to do all these socially anxiety-provoking behaviors. And what we found is that although there was no difference reported between the groups in terms of how stressful they thought it was, their autonomic functioning, their heartbeats, they actually weren't as anxious in terms of physiologic measurement, which I think is really interesting that we had both inflammation. So if I go back to my model, we had both inflammation decreased and autonomic regulation decreased. So 2 parts of this model. And that was enough to get us a funded study from NIH. So National Institute of Mental Health funded a study for us looking at a different immunoregulatory probiotic for PTSD. This is just for PTSD, but I want to tell you, very few veterans don't also have a history of TBI. Here you see again this idea of this life history, that genetics, adverse childhood experiences, decreased microbial exposure, maybe living in urban environments, over antibiotic use, leading to then a traumatic event, increased intestinal permeability, inflammatory responses, impaired HPA access, chronic systemic inflammation, PTSD, and then we go on to develop a more sustained PTSD-related disorder. So this study, I should say, we are at, I just saw the numbers yesterday, I think we're at 90 some people in, 93, I think yesterday. that may not be totally correct, 92 or 93, we need 100. So we are about 7 away from completing this study. So super excited to maybe come back and tell you how this worked. So what can I do to prevent suicide today? Well, certainly I've talked about a number of things. One thing is to have discussions about firearms. And I am horribly ignorant about what firearm-related laws are in Ukraine. And I know that things are very active there, and I'm guessing people have firearms. But what do we do to give people some time and distance between themselves and their firearms when they are very, very suicidal, particularly if people have firearms in their homes and they feel like they need to have them there to be safe? How do we create environments during particularly dangerous times to make sure that folks do not have access to those in those moments? And I also want to just highlight how do we make sure that we are assessing for things like PTSD, mental health, and other conditions. The other thing I just want to highlight, this is something that we've been doing in the US, and then this is, I mean, I think in some ways similar to what you're doing, but these folks that have co-occurring mental health problems, PTSD, TBI, these are just really challenging cases. And one thing that we've been doing with each other is providing consultation. So in any way that like we can, or you all can help provide consultation to each other to make sure that folks have the best possible resources. And that also, I think some of this is not being alone in it together. And I'm just really grateful to be able to be with you all today and not be a part of kind of not being alone in working with challenging cases together. And so thanks for inviting me. And also just want to highlight that some of this work will be presented at the Brain Injury World Congress in Montreal, Canada in 2024. And this takes so many people to actually do this work, and just really grateful to be able to present to you all today. And thanks for putting up with my fast talking. You're not the first persons who have told me that I'm a fast talker. So I'm working on it. And that's what I've got for today.
Дякую вам, пані Ліза. Зараз я передаю слово Ользі Склянській для запитань. Пані Ольго, будь ласка.
Доброго дня, дуже вдячна вам за таку підтримку і таку важливу доповідь. Рада долучитися до цього проєкту. І я згрупувала питання, які ми отримали на декілька груп. І в першу чергу хочу поставити питання, які стосуються саме військових, і які пов'язані із підтримкою військових. Отже, які можливі заходи для запобігання ускладнень на лінії фронту? Або які ви можете порекомендувати способи самопідтримки для бійців, щоб уникнути таких ускладнень, про які йшлося?
I think great question. And I think a twofold response to that. In terms of the front end, obviously, I think, you know, if we can avoid individuals getting a brain injury in close proximity to a brain injury, that's very, very important, right? So we would be better off, all of us, if we could protect people to some degree for some amount of time. Interestingly, and this comes from the sports literature more than the military literature, it used to be that we thought that people needed to rest, right? There was this whole rest thing about brain injury. What we are finding out now, and again, based on sports, but not military, but I think it can be extrapolated, is that actually activity is good and important, and rest is not as important. So we don't want injury, but we don't necessarily want rest, okay? And so what we want to do is to keep people engaged. We want to keep them active. And what we have found in terms of sports is that you can actually do some challenges in terms of symptoms so that getting people back to activities And, in sports, they're doing like exercise activities and trying to build some hardiness around those activities and teaching people that it's okay to have some symptoms. Their post-concussive symptoms are not dangerous, and that we want to kind of increase hardiness and keep people actively engaged in exercise and keep increasing the amount of activity. And as the activity increases, the tolerance and the headaches, like say, for example, will go down. But again, this idea of total rest is no longer accepted, and we should not be doing that. That being said, if, being on your computer and playing games 10 hours a day is making your headaches insane, don't do that. But also don't go to a dark room and be isolated and not active and involved. So trying to find that kind of right balance. And then again, teaching folks that being productive, being engaged, and that your symptoms are not dangerous, and it's okay as you get back to life to have some symptoms. I hope that those are several helpful things, but don't get more brain injuries in the meantime, if you can help it.
Дякую. Наступне питання продовжує цю тему. Чи вважаєте ви, що корисною буде робота з психологом або з психотерапевтом, або на першому місці медикаментозне лікування?
In terms of, I'll say for initial injury, what we've really found the best thing is just time and engagement. And in terms of expectations and help, what we've also found is helping people get back to sleep is really, really important. And so encouraging good sleep hygiene and, making sure that people are not napping too much during the day, keeping people up during the day, trying to get them sleeping at night, and getting people's sleep cycle back on track is super, super important. Medication's not often particularly helpful with that. I'm not a prescriber, so I don't want to get too far into the medications, but what we have found is expectations regarding symptoms. Symptoms are not dangerous. I'm talking about TBI symptoms, mild TBI, concussion symptoms. They will decrease over time, stay actively engaged, sleep, and then if things persist, so again, if these symptoms don't go away and you're starting to have persistent symptoms, then what we have advised folks is that you need to treat the symptoms. There aren't good treatments for TBI, mild TBI. There are good treatments for symptoms. So then you want to treat, if let's say the symptom is headaches, let's treat the headaches with evidence-based practices. If the symptom is mood, let's use the best treatments for mood that we have, right? So what you want to do is make sure that folks have, evidence-based treatments for depression, evidence-based treatments for insomnia, evidence-based treatments for headaches, right? And treat the symptoms maximally. At the same time, you're encouraging not misinterpretation of pain or symptoms as being dangerous, and function.
Дякую. І мені здається, ви вже відповіли на наступне питання. Наші слухачі просять конкретних прикладів, зокрема, яку можна психоедукацію провести з бійцями для того, щоб надалі уникнути погіршення ситуації. І мені здається, що саме про це ми щойно і говорили. І таке конкретне.
Can I say one more thing about that? Yeah. So part of the hard thing I think for us was we were kind of learning a lot during the time, and we saw people, particularly myself, I saw people long after they're thinking it was just far down the road for a number of reasons. I think just really challenging. Things had already kind of solidified by the time I saw them psychologically, and in many other ways. A researcher, Jenny Ponsford, set function, and they're getting brain injuries on top of that. So what is the context in which the brain injury is happening in? And I, of course, can't read it. I can see the text, but I don't chat, but I don't know what that means, but happy to answer if I wasn't clear too.
Мгм. Продовжує нашу тему. Чи правильно ми розуміємо, що лікування запальних процесів значно зменшує ризик ускладнень після ЧМТ? Ви сказали про пробіотики, про нормалізацію сну, які іще протоколи лікувальних
And I would say that the probiotic research is, and that's the theory, right? So that's the theory that I'm working with, that if we could decrease inflammation. Although I do have to say that there are existing studies that show that if we can help people regulate their sleep, their post-concussive symptoms go down and their mood-related symptoms go down. So sleep, I'm going to tell you all the things that are not fun, that nobody likes. Sleeping, exercise. Exercise has been shown to decrease post-concussive symptoms, also known to impact inflammation, right? So sleep and exercise, two things for sure. Hopefully, we can find other things like probiotics that could help be a part of the puzzle that is not evidence-based yet. And then, but we also, and it may not be for everybody. And there also have just been, so like anti-inflammatories have been used with mental health conditions in the past, with some failed trials. Some of those failed trials, the idea is that it's actually personalized. It's for the folks who have inflammation ahead. You remember very early I talked about the influenza slide. Those who didn't have inflammation to start with probably aren't going to have increased inflammation with the exposure. So it may be that like there's a certain group, and I should have said for our clinical trials, you have to have inflammation coming in to get these probiotics, right? So what are things that we know kind of may impact certain groups of people, or, things that we know that are inflammatory reducers that could help everybody, right? So again, things that I would think about is sleep and exercise are two huge things that we can get people doing. And I think the exercise piece is particularly important because we know that exercise, there's some studies that show that exercise is as good as other first-line treatments for mood, right? And that often people after brain injury don't want to exercise. They don't feel like exercising. They feel like they should rest, which is the opposite of what they probably should be doing. So how do we help keep people get active? I'm sorry, I don't have anything magical though.
Там ще є питання від Джима. Джим залишив питання і вийшов. То як зробити правильно? Яну, скажіть нам прочитати чи перекласти, чи ви разом з Василем перекладете і прочитаєте?
Jim's question, Lisa, had to do with, given the heavy artillery battles that are going on in the Ukraine, what are the likely impact of the combat operations on the soldiers in Ukraine when it comes to traumatic brain injuries, concussion, suicides, etc.?
So, yes. So this is actually getting a lot of interest here in the press right now too, but also this idea of blast injury. I said that a TBI is an injury event with an alteration in consciousness, right? But there's a lot of interest in like subconcussive blast and blast exposure. And we just published a paper looking at breachers. So this is folks who do blast-related training, right? So they're not getting a brain injury. They're far enough back, but they're still blast exposed because they're exploding ordnances and bombs as part of their trainings. And what we found is that they did have increased levels of gut permeability, leaky gut, so that even though it was like what it was acceptable exposures, those acceptable exposures were still related to intestinal permeability. And those were also related to post-concussive symptoms, that gut permeability. So I think we are not totally clear on whether you actually need to have a brain injury to actually have some of the negative effects. And, part of my questioning is the subconcussive blows enough to do the microglial priming? Or if you've already been, this is like you already have had 3 TBIs, is a subconcussive blow enough to actually result in more physiologic bad outcomes? And I wish I could tell you that I knew the answer to this, but I don't. We have a very large study right now. What we're looking at RNA also, and actually I'm happy to send along some of these. The protocol for that study was just published, but I'm happy to send that along. But does this subconcussive blast create RNA changes that actually increase the risk of developing things like mental health conditions and stuff? So I just think we don't know, but we do want to decrease exposures, right?
Так, і схоже питання було задано нашими глядачами, чи можна відносити до такого ризику, про який ми зараз говоримо, акубаротравми у цивільних. І на це питання ми теж з вами відповіли, будемо вважати.
I'm sorry, civilians, yes, yes.
Так. І є таке конкретне питання, яке я не можу проігнорувати, можливо, у вас буде відповідь. Чи є сучасний спосіб прибрати дзвін в голові після легкого черепно-мозкової травми?
No, I'll say no. Yes. Yeah. I mean, I wish I could say yes. There's been, tons and tons of resource have been put in. I'm sure Dr. Castor could talk about this better than I can, just in terms of sensors, right? Helmet sensors, both in terms of military and in terms of sports. And I think we are not where we want to be in either case yet. Dr. Castor, would you agree with that? Okay. I'll just say one thing that is not particularly helpful, but it's helpful in terms of my clinical interviews, and it's